Hello, dear students of the third prep grade, and welcome to a new episode of our program. It's time for mathematics, and on this episode, we'll be discussing one of the algebra's lessons, the first lesson actually, and this is called the Cartesian product with our teacher of mathematics, Mr. Ahmed Saeed. Let me first welcome him. Hello, Mr. Ahmed.
Hello, Mr. Rasim. Hello, everybody.
So let me just remind you that we're with you on air, and you could call us if you've got any questions on our phone number 25756-187. Do call us on this number if you've got any questions. We're discussing this lesson, the Cartesian product. So let me first ask you, Mr. Ahmed, as a background to this lesson, about the difference between the set and the ordered pair.
Perfect, Mr. Yasef. Before studying this lesson, we are going to revise the difference between the set and ordered pair. For example, if I have a set of numbers like 3 and 4, this is called set. The set contains many numbers, maybe 3, maybe 4, maybe 2 numbers only. Okay? And the ordered pair. Here we have the set, put two braces like that, put 3, 4. But the ordered pair equals like 3 and 4. Okay? The order in set is not important because we can say 3 and 4 equals 4 and 3. It means the order in set is not important. The same because the elements 3, 4, the same like 4, 3. But in ordered pair, the order is important. We say 3 and 4 not equal 4, 3. The first number is 3, the second is 4. But here, the first is 4, the second is 3. So we say here, the order in set is not important, while the order in the ordered pair is very important, because my name is Ahmed Saeed, not my name is Saeed Ahmed. The order in the set is not important, while the order in the ordered pair is very important.
Yeah.
Okay. If you talk about here how to perform the Cartesian product, the Cartesian product is considered of a special product. For example, if I have set like 3 and 4, okay, and this set we want to find its product with another set like set of 1. To find the answer of this question, we are going to make distribute. How to make distribute? Make a set, okay, and try to make 4 with the first number, which is 1, 3 and 1. Okay, next 4 and 1. The second ordered pair, it will be 4 and 1. We simply say that to find the Cartesian product of any two sets, we are going to distribute each element of the first set with each element of the second set as an ordered pair. Okay?
All right. What about the... do you have anything to say before we move to the Cartesian product?
Yes. The Cartesian product, as you said before, is considered of a special product.
Yeah.
Is multiplying between two sets, but in a different way.
So do we have a definition for it?
The Cartesian product it had no definition because it's considered as a special product, a special multiplication. For example, if I have two sets like x with numbers 1, 2, 3, okay, and y equals numbers 4 and 5. Simply to find x product y, we have to find x product y. This symbol says product, not multiplication. To find the answer, just we make the first element 1. Write 1 with 4. Okay? And the same number, which is 1, 5. When it's finished, goes to second element, which is 2. 2, comma 4, 2, 5. 2 is finished. 3, 3, 4, 3, 5. Okay?
Yeah.
Now what about if you want to find y product x? Y product x. So in this case, we are going to start with elements of y. يعني هقول 4 with 1. 4, 1, 4, 2, 4, 3. 4 is finished. Okay. What about 5? 5, 1, 5, 2, 5, 3. Okay. What about the graphical representation of this ordered pair or this Cartesian product? We have two diagrams to represent any Cartesian product. If you want to represent x product y, we have two types of diagrams. The first one is called Cartesian diagram. Okay. The second one is called an arrow diagram. How to find Cartesian and the arrow diagram? We have put here x and put here vertical is y. X equals the numbers or the elements 1, 2, 3. And y equals 4 and 5. If you want to find x product y on the Cartesian diagram, we just make dots with each element of x with each element of y. It means 1 with 4, put x or dot or anything. 1 with 5, 2 with 4, 2 with 5, 3 with 4, 3 with 5. Okay. What about the second type of diagrams, which is called an arrow diagram? We make two columns. Very simple way. Put there on the first column x represents x. The second column represents y. Then put the numbers of x or elements of x. 1, 2, 3. What about y? Y is 4, 5. Then, in this case, we are going to make arrows from each element of x goes to each element of y. It means 1 to 4, you can arrow. 1 to 5, 2 to 4, 2 to 5, 3 to 4, 3 to 5. Okay?
Yeah.
So we can represent any Cartesian product use two types. The first one is called Cartesian. The second one is called an arrow diagram. Okay?
All right. Can we have some examples?
Mm-hmm.
All right. Let us discuss this set of 0
Mm-hmm.
product set of 3.
Okay. Set of 0.
Product set of 3.
Set of 3. Here we have two sets. The first one has one element, which is 0. The second one has 3. To find the answer in simplest form, we can put two braces like that and make order the pair. Write in the first element the number in the first set, which is 0. And put the second element in the second space, which is 3. So we have the final result equals the set of order of the pair 0 and 3. Okay?
Yeah.
Just only. That's all.
Okay. Let us have another one.
Mm-hmm. Go.
This one is a bit, more complicated.
Mm-hmm.
It says set of 2 and 5
set of 2 and 5,
product set of 3 and 4.
set of 3
And 4.
and 4. Very simple. We have two sets. The first one with elements 2 and 5. The second one with elements 3 and 4. We just distribute, as we learned before, just make two braces. The first element is 2 distributed to 3 and 4. It will be 2, comma, 3, the first ordered pair. Okay? 2 and 4. 2 and 4. Okay? Top. What about the second element, which is 5? The same way, we can make 5 distributed among 3 and 4. We just make it 3 as the first element. Sorry, 5 the first element with 3 and 5 comma 4. Okay?
Yeah.
You will just distribute the first element from the first set, distributed among the elements of the second set in order.
Okay, let us have this example. If x equals 2, 3, set of 2, 3, and 5, all right?
X equals set of 2,
3 and 5,
3,
and y
and 5,
and y equals set of 2,
set of 2,
then y product x equals
y product x
equals.
Ta. Here we start with the set of y. So we can here make y distributed to the elements of x. Means we start with the element belongs to y, which is 2. Make two braces. The first one equals 2. 2 distribute among 2, 3, and 5. So make it 2, comma 2. The second element, our second order pair, it will be 2, comma 3 in order. Okay, while the third element, which is 2, comma 5. Okay?
Yeah.
If you want to say something here, you have the set of x with elements 2, 3, 5, and the set of y with only one element, which is 2. If I want to ask a question, what are the number of elements, or what's the number of elements of x? Or what is the sample for number of elements of x? We say n of x to represent the number of elements of x. طب here, how many elements? Here we have 3 elements. So we can say here n of x means number of elements of x, which is 3. طب. And the same way, if I say n of y, it means how many elements of y? We have only one element, so we can say here n of y equals 1 element. طب. Another question, what about n of x product y? N x product y, count how many order of the pairs of y product x. Here we have 1, 2, 3. So we can say n x product y equals 3. So we can say in other words, if I have two sets like x and y, then n x product y is given by the number of elements of x multiplied by the number of elements of y. Very important remark. يعني لو عندي two sets with elements like x equals 1, 2, 3 and y equals 5, 6. The question now, n of x, count how many elements of x? 1, 2, 3. Just put here 3. Okay,
Yeah.
n of y. How many elements of y? Only 2 elements, which are 5 and 6, equals 2. To find the number of elements of the product x product y, we make it. Just multiply number of elements of x, which is 3, multiply number of elements of y, which is 2. Finally, we say 3 times 2 equals 6 elements. So if you do the opposite, it means n y product x. I think the answer doesn't change, because we can say number of elements of y, which is 2, times number of elements of x, which is 3, then 2 times 3 equal 6. So we can say finally, we can put a rule, which is n product of x product y equals n y product x. Okay, very important rule.
Okay, another one.
Yes.
It says if x product y,
If x
product
product
y
y
equals set of 5, 3
5 3
and 2, 4,
2 4.
then x equals what and y equals what?
Good. This question is considered the opposite of the previous. يعني كان في الexample اللي فات we have two sets and we find the Cartesian product. But here in this question, the Cartesian product is given and we want to find the set of x and y. Okay? We just observe the first element in each bracket, which is 5 and 2. We say that the first number in the order of the pair represents x. So we can put here x up 5 and x up 2. So we can see here x equals the set of 5, 2. But what about y? The first numbers are x. The second numbers, I think, it will be y. So I can see here the set of y equals the set of numbers 3, 4. You can check your answer by do the opposite. How to do the opposite? It means if you have two sets, 5, 2, 3, 4. Okay? Now, to find the answer, we can say it. 5, 2, 3, 4. We can put here 5, 2 and 3, 4. Okay? But we have an important note here.
Yeah.
What about if I have only one set, like x with numbers 3, 4, and we want to find the product of x times itself. So we want to find here x product x, x product x, or x squared. The same idea, x product x and x squared. Then to find the answer, we can make it. You can repeat the set x another time. It means 3 and 4. We have another set, which is 3 and 4. You can make it here 3 and 4 product 3 and 4, because here x product x means x repeated twice. So we can make here 3, 4 product 3, 4. To find the answer, I think the same way can make distribute 3 with 3, 3 with 4. You have 3, 3, 3, 4. But what about the second element? 4, 4 with 3, 4 with 4. We can make it here 4 and 3, The last one is 4 and 4. Okay, we have here a new question. If I have x with elements 3 and 4, then can you find n of x? Very simple. Count the number of elements of x. Here we have 2 elements, so n of x here equals 2. What about if I want to find x squared? As we said before, 3, 3, 3, 4, 4, 3, 4, 4. If you want to find n x squared, just count the number of ordered pairs. Here we have 1, 2, 3, 4. So we have 4 ordered pairs, then 4 is the answer. Can you find the answer in another way? Sure. If I have x, element of x equals 2, then n x squared, you can square the number of elements of x. يعني هقول 2 power 2, which is 4. You can square the number of elements of x to get the answer. Okay?
Yeah. Let us have another one. All right. If x equals a set of 5, 4, and 3.
X equals set of 5.
5, 4, and 3.
4 and 3.
And y equals a set of 2 and 7.
2 and 7.
Then 2 and 4 belong to
2 and 4. Very important question. Here we have 2 and 4. The first question here we have x equals 5, 4, 3. The set of y of elements 2 and 7. Then 2 and 4. Ask yourself, which set 2 is belong? Yani x or y? 2 belongs to y. So can you put here 2 belongs to the set of y. Now, what about 4? 4 belongs to the set of x. So can put here x. You can just replace each number by the set containing. يعني هقول طالما 2 belongs to y, it will be y. Product 4 belongs to x, it will be x. So the answer will be y product x. If I want to continue, 5 and 7 belongs to what? I think the same way. 5 and 7, 5 belongs to the set of x, so put here x. 7 belongs to y, put here set of y. And you can replace the numbers by the sets. 5 belongs to x, you can put here x, product. 7 belongs to y, you can put here y. So the answer will be x product y. Okay?
Okay. Now, if 5 and 7 belong to x, y,
5,
then
5 and 7 set or ordered pair?
No, ordered pair.
Ordered pair, yes.
Yeah. Belong to
5
x,
and 7
product y,
belongs to x,
product y. Then space belongs to x and space.
And space belongs to y. You mean that?
I'll say it once again. If 5 and 7 belong to x, product to y, then space
belongs to x,
and space belongs to y.
To y, perfect. Here we have. In order, the pair has 2 numbers. Okay, the first number always represents x. You have put here x, and second number represents y. So we can put here y. So any the first number is called the first projection, or always belongs to x. The second number belongs to y. So can say it 5 belongs the set of x, and 7 belongs the set of y. Here we have, again, here we have 5 and 7 belongs to the Cartesian product, which represents x product y. That means the first number is the first set. The second number belongs to second set. Very simple. So 5 belongs to the first set, which is x, and 7 belongs to the second set, which is y. Okay. Here we have an important item before following or continue this part,
Yeah.
which is when two ordered pairs are equal.
Yeah.
When two ordered pairs are equal. If I want to make graph, as we said before, the ordered pair 3 and 1, for example, not equal the ordered pair 1 and 3. What is the reason to prove this point? On the graph we have 1, 2, 3, 1, 2, 3 vertical. Okay, the ordered pair 3 and 1, you can put 3 and move up 1 unit. So this ordered pair represents 3 and 1. So what about the second ordered pair, which is 1 and 3? 1 and move up 3 units. It will be 3, it will be 1 and 3. We have different positions, so we say 3 and 1 not equal the ordered pair 1 and 3, because here we have two different positions. Okay, the question now, when two ordered pairs are equal. لو عندي 2 ordered pairs امتى اقول انهم يكون equal؟ Simply, if the first number here equals the first number here, and the second number equals the second number. For example, if I have A and B is an ordered pair, the second one Y and X, here we have two ordered pairs separated by an equal sign. So we can see here the two ordered pairs are equal when the first number in the first ordered pair equals the first number here, the second equals the second. So we can say here A equals X and B equals Y. Okay, like X and 5 equal 7 and Y. Can you find X and Y in this question? Here we have two ordered pairs, X, 5 and 7, Y. To find the value of X and Y, we just circle X, the first number, with 7. So we can make it X equals 7, and underline the second numbers 5 and Y. Finally we can make equal Y equals 5 in a simple way. Okay.
Yeah. All right. If X equals a set of 0, or let us say set of 6.
Sorry.
If X equals a set of 6, then X square equals what?
Then
X square
equals
what?
Good. We have a big difference between x squared and nx squared. To find x squared, the common mistake of the students, we have x equals 6. Then x squared, you can square the number of 6, which it says 36. So it's false, because we are not square the number, we just repeat the set twice. يعني هقول 6 product, repeat the set. Product 6 equals, the answer will be set of ordered pair 6, comma 6. Now what about 36 is a false, because we not square the number, we just repeat the element.
Yeah.
If I have 5, then x squared will be 5, comma 5. If the x equals 7, x squared equals 7, comma 7. If I want to find here n x squared in this question, ask yourself, how many elements of x? Just one element. Just one element. So we can make 1 times itself. 1 times 1 equals 1. Because x squared has only one bracket. Okay?
Let us move
Okay.
to another one.
Yes.
Okay. This one says if x equals 5 and 3, then no, let us have this one. X equals, or let us say x product phi equals what?
First, what is the meaning of phi? Phi is an empty set, nothing of elements.
An empty set.
An empty set, nothing of elements. No elements in this set. We say here, phi equals empty set, no elements in between. So if I have any set like x product phi, what is the answer? For example, x equal, for example, 1 and 2, product phi. Phi is an empty set, but how 1 product e, and there is no elements, so the answer equals phi. So we can put here an important note. This note says that x product phi equals phi. طب هل x بس؟ لا, any set product phi equals phi. And if I say here y product phi equals phi. طب another one, 1 and 2 product phi equals phi. Okay? طب يبقى x product phi equals phi. We can put here any set product phi equals phi. Okay?
Okay, let us now have a little break, and we'll be back right after the break, so stay with us.